Welcome to our channel. In today's video, we're diving deep into a vital aspect of software development, code coverage analysis using the debugger. If you're looking to enhance the quality of your Java applications, you've come to the right place. First, let's clarify what code coverage is. Code coverage is a measure that tells you how much of your code is being executed during testing. It's a great indicator of whether your tests are thorough enough. Let's take a look at the types of code coverage metrics we typically examine. There are several types of code coverage metrics, including line coverage, branch coverage, and method coverage. Line coverage measures the percentage of lines executed, branch coverage checks whether each possible path through a branch was tested, and method coverage looks at whether each method in the code was called during testing. Next, let's set up our environment. We'll be using an IDE that has an integrated debugger, like IntelliJ IDEA. Make sure you have Java installed and your IDE set up to run Java applications. If you don't have IntelliJ IDEA, feel free to download it from the JetBrains website. Once your environment is ready, let's create a simple Java application for our demonstration. Open your IDE and create a new Java project. For this example, we'll make a project called Code Coverage Demo. Inside this project, create a new class named Calculator. Now that we have our Calculator class, let's add a class for testing. Create a new class named Calculator Test. We'll add some basic unit tests using JUnit to check that our calculator's methods behave as expected. With our tests in place, let's run them to ensure everything works correctly. In IntelliJ, you can right-click on your test class and choose Run. You should see a green bar indicating that all tests passed successfully. This is important because it sets a baseline before we start doing our code coverage analysis. Next, it's time to analyze our code coverage. We will accomplish this by using the built-in coverage tool in IntelliJ. To do this, again right-click on your test class and choose Run with Coverage. Once the tests run with coverage, you will see an additional tab with coverage results. This tab displays which lines of code were executed during the test. Let's examine the results carefully. In the coverage results, you will notice lines highlighted in green. These represent the lines that were executed. Lines that were not executed will appear in red. Based on our simple calculator test, you'll see that all lines in both add and subtract methods are covered. However, what if we only wrote a test for one method? Let's see how code coverage responds. To test this, let's modify our tests by commenting out the test subtract method. Save the changes and run our tests again with coverage. Let's see how the coverage report looks with this change. After running the test with coverage for the modified tests, you will now notice that the coverage report indicates that the subtract method has not been executed, as indicated by the lines highlighted in red. This is a clear example of how code coverage helps us identify untested parts of our code. Let's add another method to our calculator class, one that can multiply two numbers. We'll also add a corresponding test to ensure it works as expected. Now let's add a test for the multiply method to our calculator test class. After adding the multiply method and its test, run the test suite again with coverage. You should see that the code coverage has now increased as the new method has been tested. This shows how adding tests can help improve your code coverage metrics and increase confidence in your code's reliability. Understanding code coverage is just one part of the puzzle. The true value comes from analyzing it critically. A high percentage of coverage does not always mean you have quality tests. It's essential to ensure that your tests cover edge cases and possible failure scenarios as well, so consider focusing on meaningful tests rather than merely increasing coverage percentages. Let's explore how to interpret the coverage reports effectively. Look for critical code paths that may not be covered by your existing tests. Pay attention to methods and branches that are not executed to determine whether they require additional tests. This is where the real insight of code coverage can be found. One more useful tool in IntelliJ is to view coverage data in the form of a percentage. You can find this data in the Coverage Tool window, where it summarizes the coverage metrics at different levels: class, method, line, and branch coverage. If you're interested in going deeper into specific tests, you can also set breakpoints in your code. This allows you to step through each line of code during test execution to see exactly which parts of your code are being triggered and which aren't. To set a breakpoint, simply click on the gutter next to the line number in your code. Once you've set a breakpoint, run your tests in debug mode. You'll have control over the execution, allowing you to step over or step into each line of code. Let's try debugging one of our methods now. Run your calculator test using the debugger and observe the execution flow. You can take note of the current values in variables and see the state of the program at different points of execution. This gives you an incredible insight that complements code coverage analysis by letting you visualize what logic is hit. As you become more familiar with these tools, they will allow you to quickly iterate on tests and write more effective ones. Remember that the ultimate goal is not merely to increase code coverage, but to ensure that your application is robust and bug-free. Now, let's discuss some best practices for using code coverage in your development process. Firstly, strive for meaningful tests that verify the functionality rather than simply achieving high coverage numbers. It's not about quantity, but the quality of your tests. Secondly, regularly review your coverage reports as part of your development workflow. Integrate coverage analysis into your CI/CD pipeline whenever possible to continuously monitor test effectiveness. Finally, don't forget to update your tests as your application evolves. When you add new features or refactor existing code, ensure you have corresponding tests that maintain or improve coverage. As we wrap up today's discussion on code coverage and debugging techniques in Java, I encourage you to put these practices into action. Start with a simple application, experiment with adding tests, and then analyze your coverage to find gaps. Debug your tests for additional insights. Thank you for being with us today. If this video helped you understand code coverage analysis using the debugger, please hit that subscribe button and give us a thumbs up. If you have any questions, feel free to leave them in the comments section. Happy coding!